Hello Algebra 2. This is the video lesson for chapter 5.4, which focuses on complex numbers. Let's pick up where we left off with the last lesson and the last section that we looked at right before our most recent quiz. We might have had a problem a lot like this, and I might have asked you to solve for x. So the first thing that you would have done would have been to move over the 42, and then you would have ended up with 2x squared equals negative 32, and you would have divided by 2, and you would have ended up with x squared is equal to negative 16. And maybe you've already seen before we got to this point, but hopefully you see at this point that, wait a minute, I'm now saying that a squared value is equal to a negative, and maybe some little alarm bells going off saying, now you can't do that. You can't have you can't take the square root of a negative. You can't have a square turn out to be a negative. Even any negative that you can think of, such as negative 4. Negative 4 times negative 4 turns out to be positive 16. So we run into this a lot in math, more often than we'd like to admit, and certainly in the sciences as well. And the reason that we ended up developing this concept called complex numbers is to deal with this fact. And we ended up deciding, it certainly wasn't me, and it certainly was something that was concluded and agreed on more than 100 years ago, that we would come up with a concept called I. I stands for imaginary, and I is the imaginary number, the square root of negative 1. And when you run into a situation like, well, here I've presented the square root of negative 19, what you do is you pull out that square root of negative 1 as a factor, and it becomes I root 19. So let me show you what it would look like with the example I'd given you. We had x squared equals negative 16, and that's where we realized we were stuck. Well, we could change that to the square root of both sides if we were just willing to live with it for a minute here, and it becomes x equals plus or minus the square root of negative 16. But now factor out that I, that square root of negative 1. And once you do, now you've got something that you can live with, as long as you are willing to live with this imaginary concept for a minute. It's kind of like watching a movie that you know can't possibly happen, but as they say, you suspend disbelief for a while just to go along with the movie. We'll go along with this movie for a minute. Now I've got 4 here. That's what the square root of 16 is. So I've got 4 times plus or minus I. And typically we don't write it here. We feel it's a little neater to write it as plus or minus 4I. And that's the way we would write the solution to the problem that I'd given you at the very beginning of this video. Now, one thing I've neglected to mention is this whole video lesson is designed to go along with a document I've created, a guide for the properties of I, or ways of working with complex numbers. And you'll find that on the website right next to this link to this video. So let's look at a next step from this. If we accept that I is the square root of negative 1, then I times I, or in other words I squared, is this times itself, and that would be negative 1 without the square root symbol. So I squared is negative 1. If you accept that, then 27I squared is 27 times negative 1, or in other words negative 27. And similarly, negative 27 times that negative 1 is positive 27. So what this means is that I squared, when it's multiplied times anything, simply changes the sign on the coefficient it's assigned to. So you can actually end up using this to take some shortcuts. 27I squared is 27 times negative 1. Okay, so it's negative 27. And negative 27I squared, okay, well that's negative 27 times negative 1. That means it's positive 27. And in fact, as soon as you see I squared, you can simply think of it as the thing that changes the sign of whatever it's being multiplied against. So let's move on to a next case here. The next part of the guide that I suggested you print out, or at least look at on my website, talks about how to solve equations when you do have a negative square root. So I'm going to work through this first example, and then you're going to help me work through the second example. In the first example, I've got this statement here, and I move the 7 over. Or actually, I'm sorry, I guess I've decided to move the 3x squared over. So I move that over, and I've got negative 7 on the left. On the right, 4x squared minus 3x squared leaves me with x squared. So I've got x squared equals negative 7. Well, now I've learned what to do about that. But before I go any farther, I want to make sure that you don't forget, whether you're working with imaginary numbers or the numbers you're more comfortable with, whenever you're taking the square root of x, there are two possible answers. So make sure you remember to use plus and minus. So here's step 3 now. I guess actually you go straight from step 2 to step 4 in my guide. You would factor out I. In the next example that's here behind the gray curtain here, you'll see why step 3 sometimes is necessary. So I'm going from here. I'm factoring out the negative 1 as I, and I've got plus or minus I root 7. So now, as promised, let's look at that second example here that you're going to help me with. I've got 1/3 times this binomial squared equals negative 7. Well, I'll spot you the beginning. I'm going to move the 1/3 to the other side by multiplying both sides times 3. Hit the pause button, jot down for yourself what the result would be, and then I'll reveal it. I'll do that each step of the way. Okay, I'm going to assume that you did that, and you should now have just plain old x minus 5 squared equals now negative 21. Okay, again, hit the pause button. See if you can figure out what the next step is going to say. Okay, again, assuming you did that, I'm going to assume that you took the square roots of both sides. And now you should have remembered the plus and minus there, and you should have plus or minus the square root of negative 21. We'll move to the next stage. And we've already done that plus or minus, so now we come to that step 3, that I said before is sometimes necessary. I've got x minus 5 equals plus or minus something. I got to move that 5 over. So write down what it would look like if it were just x on the left. Okay, this is what I meant. You've moved the 5 over, and now it's 5 plus or minus the square root of negative 21. Now the last thing is, don't leave it as the square root of a negative. Write I instead. And you should write it like that. 5 plus or minus I root 21 is the answer, and that's as far as I can go in terms of solving, or in this case factoring, or in this case solving for x. Sorry. So next slide. I want you to try to do 3 and 6 and 12. All by yourself. Hit the pause button. When you come back, I'll show you the answers. Okay, I'm going to assume that you've worked out all 3 of those. I'll show you the answers for 3 and 6, and then 12 is a little more complicated. I'll walk you through that one. There are the answers for 3 and 6. You should have gotten plus or minus 12i for 3, and plus or minus 2i for question 6. If you didn't get those, feel free to hit the pause button and study this for a second to see all the steps that I've worked through. Otherwise, I'm going to walk you through number 12. Now in this case, again, I'm going to move the 3 over. So I'm going to have just, why is that not dragging? X plus 5 on the squared on the left equals negative 49. Taking the square roots of both sides, I've got x plus 5 equals plus or minus the square root of something that almost looks like a perfect square. I factor the I out, and I skipped a step here. The square root of plain old 49 would have been 7, so this is plus or minus 7i. And then, lastly, I move the 5 over. Sorry about that. And I've got x equals negative 5 plus or minus 7i as my answer for number 12. Again, hit the pause button and study these steps if you didn't get that answer. But I'm going to move on to the next part of the document. We can combine binomials, or larger, we'll talk about polynomials later, but larger strings of numbers that have I in them. The one on the left here, all you're really doing is combining the like terms. You're pulling the like terms together, the 2 and the negative 8, as this step says over here. The 2 and the negative 8 become negative 6. Combining the terms that have I in them, the 3i and the 5i, those collectively make 8i. You treat I, in this case, almost like it's a variable, almost like it were 8x, and this had been 3x plus 5x. Subtracting isn't really any different. I'm going to put the 5 and the negative 7 together. Similarly, the 6 and the minus 4i together, and you should end up with negative 2 plus 2i. I'm not going to have you do any practices with those. Instead, we're going to focus on the multiplication. If I have to multiply 2 binomials that have I in them, I'm going to use the same FOIL technique that we used earlier in chapter 5. The first 5 times 3 become 15, just as, well, I'll just do one more. The lasts, negative 4i times 6i become negative 24i squared. And cleaning this up, I'm able to put those two middle terms together. They become 18i. Now I've got a trinomial, but the key point with I, remember, whenever you get I squared, that's just negative 1. So like I said before, the nice thing about I squared, you can think of it as just a shortcut to changing the sign and making yourself another integer. Negative 24i squared automatically becomes positive 24. That 24 can now be combining like terms with the 15, and I've got 39 plus 18i. Hit the pause button if you're not sure about that, but I'm going to go ahead with your help and do example 2. You should rewrite this as 2 plus 5i times 2 plus 5i. Once you do that, then you can FOIL it. And whoops, again with that. Hang on. Okay, you should get this string. The 10i's can then be put together to make 20i. The 25i squared can be changed to become negative 25, as it is here. And then that negative 25 can be put together with the 4, and you should have negative 21 plus 20i. Okay, now hit the pause button and go ahead and do 15, 18, and 21 for yourself. When you come back, I'll show you the answers to those. Okay, I'm going to assume that you did that. 15 and 18 are worked out all the way through here in blue and in green. Notice I've given two different ways of saying the answer for each. For 15, you might have said negative 2i minus 2. I prefer, and a lot of mathematicians prefer, to put the I term at the end, so I've simply reordered it as negative 2 minus 2i. Neither of these is really better than the other. It's just convention. 18, same thing. You might have written it as negative 12i minus 28. I reordered it. 21, just to work that one through because that's the FOIL problem. You should have gotten these 4 terms and then combined the 8i and the 9i. Whoops, I did it again. And gotten 17i. That plus 12i squared should have become minus 12. Then you can put the minus 12 together with the 6 and get 6 and minus 12 become minus 6. And your final answer for number 21 is negative 6 plus 17i. Okay, moving on to the last step and the last part of the document that I gave you. Again, like with radicals, convention is not to leave, or to not leave, I guess I should say, to not leave I in a denominator, just like you don't leave a radical in a denominator. So instead, you want to get rid of it out of there. The way to do that is to use that FOIL method. And the great thing about the FOIL method, remember, when you've got the difference of perfect squares, it happens, well, you'll see why. If I had made that negative 2 plus I times negative 2 times minus I, look at what happens. First, the negative 2 and the negative 2 make 4. The outers make positive 2i. The inners make negative 2i. That's what I'm getting at. The positive 2i and the negative 2i are going to cancel each other out. And then the lasts, in this case, are going to be negative 1i squared. Well, because those cancel out, I'm left with 4 minus I squared, which in other words becomes 4 plus 1. And I'm left with just integers down here. I don't have I any longer. Well, all of this happened. The way I was able to get here was because I chose to multiply by negative 2 minus I. But I have to do the numerator the same way. I have to be multiplying by 1. So you end up multiplying binomials on the top and the bottom. This is a challenging step, I admit, and we'll end up spending some time on that. But look this over in the guide. Make sure you understand as best you can how I came up with that answer. And here is your homework for tonight. So go ahead, work with the guide in hand, go back to the video if you need to, do these homework problems, and come into class with questions. I'll look forward to seeing you next class.